Back in my day, we only had 3 speeds to select from on our speed controller, and it was not electronic. Let me know in the comments if you remember those days too. Uphill both ways, had to charge our batteries twice, couldn't look at it sideways, it was gonna burn up, and you know that they did. Originally, these ESCs, which stands for electronic speed control, originally these were mechanical devices, and I don't know if there's a lot of you that are left that even have some on the shelf or that remember those days. I have been in the hobby long enough that I had many mechanical 3-step speed controllers that essentially you would have 3 positions. We'll call this your common ground, a high resistance, a low resistance, and then straight to your motor position. So plip, 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 that's all that you had essentially. And later down the road, of course, the mechanical ones were a wiper situation, more like a linear potentiometer, to where there'd be a going across the coils, and the resistance would get lower and lower as you got towards the end. A lot more granularity in your speed control. Maybe you'd have 100 steps. It depends on how many winds were on that wiper situation. The days have changed. So we're going to talk about speed controllers today. I'm going to describe them, go through a couple of names, and then we'll get down into a little bit of the componentry, but I don't want to do too much on that because that can be a heavy video. And maybe we'll do that in the future if y'all want to see more on the components. So ESC, it stands for Electronic Speed Controller. Let me know in the comments what you may call them in your country. Maybe you're not from the US. There could be some other names for them, and I would like to know. But in the US, we usually just call them ESCs. Sometimes we call them controllers. In the e-bike world, we simply call them controllers because there was no mechanical speed controller days. In the e-bike realm, it has all been electronic speed controllers. So that is what we call them. Now, the function of the ESC is actually pretty simple. When you're looking at it from the grand view of things, it controls the speed of the motor. And we have 2 different types here. We have our brushed speed controllers, which are going to be 2 wires coming off of them, and they control brush motors, which have 2 wires coming off of them. And the commutation actually happens inside the motor. So these are really simple devices, and I'll get back to how they control that here in a minute. Then we have our brushless speed controllers, and these are going to be 3 wires. Let's see, there's 3 places to put your wires in on this one. You can see 3 wires coming off on this guy. This is a prototype of the Crawlmaster V2. And then we have another board, just so you can see. Here's the bare PCB for one of the prototypes that I made that didn't make it to final revision, but you can see 1, 2, 3. We got 3 holes for our motor wires on that side, and then we have 2 holes for our power on the other side. And all of these have power that come in. We are going to be powered directly off of a battery, which I have absolutely no, there's a battery. Here we go. There's 2 wires coming off the battery. We have a positive and a negative, and that plugs into our speed controller. Now the function, how does an electronic speed controller actually control speed? So you have your radio, which is giving it signal, and you've got a signal that's just, let's say, from your trigger pull at 0% throttle up to 100% throttle when you're fully pulling the trigger. And the ESC interprets that signal from 0 to 100%, and it gives the motor, for a brush motor in particular, very simple, a pulse width modulation, or a PWM, aka a duty cycle that matches what your finger says, more or less. Now, throttle curves and everything kind of screws with that. We need to have switching dead time added into that. We need to have our switching frequencies. There's a lot of little details that makes it slightly more complicated, but on the base of things, we can say if you're at 5% throttle, then the ESC is going to tell the motor to go 5% voltage, or 5% PWM rate, or 5% duty cycle. If you're a welder, you're going to be familiar with the term duty cycle. It's the same as PWM, pulse width modulation. So if a pulse width modulation is on 50% of the time and off 50% of the time, that is 50% PWM. It will equate to about 50% speed on the motor, and I say about because it's a brush motor and things, it doesn't quite work linearly, but at the base, I think you get the concept. So brush speed controllers, pretty simple guys. We've got a lot of options. They typically come on ready to runs. We've got this XL5, we've got this Reedy SC400X. These are your standard ready-to-runs. The ready-to-runs usually aren't that great, so you'd update it to something like a quick run, however they say it, 1080 from Hobby Wing, or if you want to go higher quality and smoother, you would go to something like a BRXL. And lots of options. Here is essentially a decased BRXL with a shrunk board. And as you can see, this is just a little bare PCB for competition guys or scalers that want to be able to shove this into a tight space. But more or less, it's the same device. So let's move on to brushless. So on a brushless speed controller, since we don't have a commutator on the brush motor, I'll just grab you one. Why not? I know I got lots of them around here hiding. But they're really hiding well, I guess. They are hiding so well that I don't see any. Maybe there's one. No, yes, there's one. If you've seen the videos about brushed motors that I've made, then you are familiar with the parts of a rotor. And this little shiny part up here is called the commutator. And what it does is it commutes the motor. It commutates the motor through the various steps. For a 3-slot, it's going to have 6 steps of commutation per revolution. 3-slot with 2 magnets at least. And the brushed ESC doesn't have to deal with that because it's built into the motor. Nice and fancy. With a brushless motor, it doesn't have a commutator built in. And that's actually a good thing because they have higher efficiency. But this isn't about the motors, this is about the ESCs. So what the brushless ESC has to do is commutate on the 3 wires and what is called 6-step commutation typically. Now, if we're going to talk about the axe system or the fusion from Hobby Wing, those use field-oriented control, which is essentially like micro-stepping. So instead of having 6 steps, you have micro-steps that lead up to basically your same 6-step commutation table. But we can imagine, here's our 3 wires, and we're going to commutate. We're going to say this one, and then this one, and then this one. That's 1, 2, 3, and then 4, 5, 6. There's our 6 steps. And that will actually progress it. If it's a 2-pole motor, that'll make it do a 360. If it is a 14-pole motor, that will make it do 1/7 of a 360, and it would have to repeat that 7 times to get a single revolution on there. That is commutation in a nutshell. The brushless ESC tells the motor what to do and how to step between those 3 phases in a pattern, just so it will work. But how does it control the speed? So we've got our commutation frequency that's going on, and then we go back to our good old friend PWM, or duty cycle, and on top of this commutation frequency, we also have our PWM. And so our PWM is essentially an on-off switch for our battery, high side, low side, really doesn't matter which way, and then we're commutating at the same time. It becomes a little complicated, but these are more smart devices. They're much smarter than a brush controller. And so not only does it tickles the motor with a little PWM at whatever frequency that it switches at, because that's a whole nother subject. It really is. So the PWM essentially sets what speed that the motor wants to see. Let's do an example. A 10-volt battery, and we're giving it 10% PWM or 10% duty cycle. That's going to be the equivalent of applying 1 volt, more or less. It's not really how it works, but for a sake of explaining it's exactly how it works. So if we have a 5,000 kV motor with 1 volt going to the motor, minus the no load losses and all that kind of stuff, we're going to see 5,000 RPM out the back side of the motor, or the front side, depending on which way it's facing, right? Then the commutation frequency of the controller has to be smart enough to make sure that that 5,000 RPM is commutating at the right speed so that things don't get out of sync. It can become quite the large project, is the easiest way to say it. Now, some of them are censored, and so they get literally mechanical feedback. It is a digital signal. You could argue with me on this, but they do get feedback of where the motor is, which makes it a little easier. But at the end of the day, these actually detect where the motor is based on the back EMF that they produce. So it's a pretty involved system. But I know I threw a whole bunch of terms at you. And for us to really get into the nitty-gritty of how it works, I'm going to at least name some of the smaller components. Let me, I'll just use this bare board right here. So really the meat and potatoes of a ESC, of an ESC, is the MOSFETs right here. So we've got 8 MOSFETs on this guy. It is actually, since it's a brush controller, it is arranged into an H bridge. On a 3-phase controller, it would be arranged into a 3-phase bridge, which is essentially 1.5 H bridges slammed together. So these switch on and off. And with the brushed motor, we can kind of do it easy. We turn, let's say, our lower gates on, and then our opposite high gates are the one that PWM, and when we reverse directions, we switch that. We turn on the opposite low gate, and then we PWM our high gates. And you can do it either way. We could PWM the low gates. We could actually PWM both of them at the same time if we wanted, but we'd have more switching losses doing that. So there's that's probably a whole nother video. If you want to see specifically commutating video, then we could get into that. But for today, the MOSFETs are the ones that get the PWM, and they are controlled by the IC, the integrated circuit. And here's this little guy, little black chip, a whole bunch of little pins coming off of it. And it essentially is what tells either directly the MOSFETs to switch on, or in a lot of cases, we'll have a gate driver in between it, and it tells the gate driver to work, and the gate drivers drive the gates on the MOSFETs, and the MOSFETs tell the motor to turn. Essentially, in a nutshell, that's how it works. Now, we may have some other components on here. We're going to have, a built-in BEC on most, if not all, or not all, but most ESCs. What we don't see on here is a power capacitor. Normally it would be attached right here. You can see the capacitors, bam, 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 on this guy. On this particular ESC, the Crawlmaster V2, it's much smaller, and so we have these surface mount capacitors all in a line. Ideally, long term, I would put a larger capacitor there as well. The more capacitance, generally the better. The lower the resistance of the capacitor, generally the better. As you can see, we have 2 power capacitors on the BRXL. We got 1 power capacitor on the 1080. It is definitely needed, because when you have this switching on and off, you get a lot of ripple voltage, you get a lot of ripple current, and those capacitors are there to essentially smooth them out. The ESC ends up seeing a much more reliable voltage coming in, and it is better for all of the components on the ESC. So as far as the subcomponents on there, that's just kind of a basic overview. We have our IC, we have either our gate drivers or just directly the MOSFETs. The MOSFETs are the ones that switch on and off. On most of them, we're going to have an internal BEC. We definitely need power capacitors. Of course, we need wires. On a brushless controller, we're going to need a bunch of voltage dividers so that we can actually sense the back EMF coming off the motor. If we want to have dual voltage on our comparator network, then we would have a low voltage resistor network that's doing the low voltage comparator job, and then we would have a high voltage comparator network that will do a better job at, say, higher speeds when the input voltage is effectively higher. The back EMF is higher coming off of the motor. And, well, more or less, there's a lot of other subcomponents that we can have on there. We need a lot of filtering, caps and resistors, RS networks on there, a shunt. I've ran out of fingers, I think. A shunt so that we can actually see what the amperage is on there. For really refined amperage control on a brushless ESC, we would have a shunt that's located on, let's say, the high or low side, depending on how we're switching it. And then we would also have at least 2 shunts on the phases as well. And that way, we would be able to see the amperage for everything, and knowing the amperage is actually a good thing, because you can save the ESC from damage, or you can control your motor better. And I think I'm just going to stop right there, because I'm realizing I'm getting really deep into the components, and I wanted to save that for another video. But in a nutshell, that is an ESC. Through the magic of electronics, it tells our motors how to go. And with the brushed, it's very simple. We just have 2 wires, and we vary our voltage up and down through the magic of PWM. And for a brushless, it essentially does the same thing, but it also has to commutate those 3 wires through the 6-step commutation, just so it can keep its act together, honestly. If you do have any more questions, if this went way over your head, if you have any questions on terms or how it works or anything like that, leave in the comments below. I'll do my best to get to them, or I will use those for a separate video in the future. So your input on this would be greatly appreciated. At the end of the day, I do thank you for tuning in, and have a good day.